Hello and welcome to GTI Predictive Technology. My name is Tom Honig. I'm going to be going over this tutorial with you of our web application. And as you can see, I have my website up now. GTI Predictive Technology has developed the iPad vibration analyzer where all the data goes up to its web app for post-processing and making important decisions on assets for both vibration analysis, thermography, and many other apps to support that for laser shaft alignment, balancing, and many other tools that are used, including phase analysis and many others. So I'm going to be showing you this. This is our website that you see in front of me. Please follow my mouse throughout this tutorial as to what I'm clicking on and knowing where to go. The first step is to go to the login, which this logs you into our web app. Normally you would put your username and password in. I already have mine in to speed this up. And this will visit you immediately with all of our tools and vibration, thermography, report center, all of the different tools that we offer here at GTI on our web app. And before I get into too much, I'm going to very quickly go over the preferences. What this allows you to do is to set all of your different preferences that you want to view when you're post-processing your data here in one spot, which is your hertz to CPM, whether you rather have different F maxes, your different bearing markers, whether you want to see more bearing markers or less, or more RPM, whether you want your temperature in Fahrenheit, Celsius, or Kelvin, and also what your order entry of your hierarchy is, from alphabetical to entry order, so forth. Also, whether you want to load your databases manually rather than doing it via the internet, you can do that as well. But more importantly here, you can put your own company logo in here, whether you're using this at a factory like Caterpillar, Honda, Toyota, Chevrolet, Ford, whatever. You can put your own logo, so all your reports will have your logo at the top. It also allows you to know what your subscription date is, expires, and what your time zone is, which is important for when your next data collection times are needed. So that quickly goes over our preferences. Another real nice feature of this is a report center. All of our different apps, whether you're in VibePro, Balance Pro, you're in thermography, or you're even in our laser alignment, you can send your reports to the report center, which allows you to click. And this is just like Dropbox. It's a repository. I can pull up a report that I did on a particular balance job, which you're going to see here, which is going to give me my time and date stamp, my original imbalance, my correction weight, the polar plot from where I started to where I ended up, what rotation I was in, and my spectrums as they decreased as I balanced it, to the picture of the unit I balanced and my setup, to the map and coordinates of where I balanced it in the United States or any other foreign country. And this will do this for any balancing or thermography or a laser alignment that you've done. You can see, I can even see where my trial weight is. You can have a nice repository for these reports. And you can also do a single measurement report in VibePro and save it there as well, which is nice. But our legacy app is VibePro, and I'm going to be centering around ThermoPro later on in this tutorial. But for VibePro, to use this web app, you simply select where you are. These are all the different people using the account, so you would select what plant or account you're at, and you would just click on VibePro. And that immediately visits you with your hierarchy, which is very similar to what it looks like on the iPad. You're going to have your plant area, your machine, your point, and your measurement. So I'll just quickly click on a point or a plant area within this particular factory, and you can see they've got a lot of areas within the plant that they're measuring. There's about 500 machine tools being measured here. There's spindles, ball screws, different components within the machine tool, which I started here because machine tools and spindles can be one of the hardest to measure compared to pumps, fans, motors, and things of that nature. And immediately you're visited with all the machines in that area, and also this nice dashboard heat map, which is going to tell us where our problem areas are. And let's drill down on that with this question mark here that's going to tell us anything we want to know about this application as far as information is concerned. Plant reports, all different parts of this that's going to tell you different information to learn from of how to work this app. But let's click on the heat map part, which you can see very clearly explains what the heat map is all about. Here's a similar heat map in the middle. It shows me why the blocks are small here in red, yellow. Our different thresholds are yellow and red threshold. You can see something that's in yellow but is a small block has been very steady and staying there for many months at a time, where conversely here a large yellow block, still yellow but large, is heading towards red in a very fast fashion, much as you see with this red one that's crossed the red. We know it's more urgent because it's a bigger block. So now as we go back and look at this actual plant, you can clearly see we know where our problem areas are. It's the large yellow blocks and the large red block. So let's click on that to start. We click on that problem area, we're met with a trend right away that tells us exactly what's been going on through the months. It crossed the yellow, very sharply crossed the red. We know we're in trouble and we want to know why. Now, a trained analyst is going to drill down to the spectrum and start doing his own analysis. But what we've done here is we've written an algorithm, much like Shazam is for music. It is going to read the spectrums that have been taken throughout that time and tell us what it thinks is wrong with the spectrum and what it thinks is wrong with this asset. And you can see we get a nice picture of our measurement point and what asset that we're measuring here, which is a spindle. A very high-speed spindle. So let's click on the fault detection button and let's see what it has to tell us. It immediately visits us with bearing unacceptable. So it's telling us that we have to plan for bearing failure. So let's drill down as an analyst and look at that spectrum and its trend and see if we agree with what our computer model has told us. And we're also visited with a nice waterfall plot, which we can click on and blow up and look at over time, which we can see our bearing defect frequencies has started very low here in the beginning, way back in 2014, and progressed very high as things went along. So that's a nice feature there as well to conclude what the algorithm is telling us. And our trend is telling us the same thing. We crossed the yellow back here at the date and the amplitude I can see back in 2015, and now at this point we're all the way above the red. So this is a very late failure. We should have probably looked at this long ago before this was measured at these points, and this is a late failure and should be immediately acted on. But let's click on the last spectrum and look at this spectrum and see that we do, which we can zoom in on these spectrums as well, and see that we have an extremely high bearing frequency pyramid going on here, which is very typical. And we're, if I click back, I can see my overall is 10 plus Gs. So again, this is a late failure, and now we've detected a problem that we can act on, and we can immediately put in a work order, do a measurement report here, or even a machine report right from the web app. Because anytime you drill down, whether you're on the point, you can do a point report. Whether you're on the measurement, you can do a measurement report, or back to the machine, you can do a machine report. And I'll click on that so you can see how that looks. Machine report will immediately pull up a report that I can email out showing our trend over time of what's been going on, the photo of our asset, and what's been going on as far as it starting out way back in 2014 is good, and to the danger level, all the way to the spectrums that it puts together, and I can email that right out to a subordinate or to a customer or what have you. So that's just one asset, but let's go back to that same area and let's let's target in on this little yellow one that isn't as important, but something's going on there and it's been there for a long time. So we can see the asset. Looks like we have some sort of coupling or shaft in the front here on this particular unit. And let's go back to the fault detection and see what goes on here. We have a 1X component in the axial direction. Check misalignment or bent shaft. So we have something that maybe can be corrected here if we have a coupling involved. If this were a motor or a pump, we could address this misalignment or bent shaft. But let's go look at this in alert velocity reading. It's been going back and forth each time it's been measured. And let's just go to the last reading and see if we agree upon that. And let's use some of the tools to detect that. So our cursor, this red cursor, well, let me blow it up so everybody can see nicely. These are some of the tools. We can zoom in on the spectrum at any point so we can see things here clearly. And this red marker here is my RPM marker, the running speed of this particular asset point. Now, I don't know if these two are multiples or not. They look like it, but I can quickly hit my markers here and determine, yes, they are multiples of running speed. So we do have something that's wobbling and giving us a problem here that's either misalignment, looseness, or a bent shaft. So again, the analysts in the market here watching this video, you'll be able to see how accurate our fault detection is working. Worked very well in both of these cases. Let's go back and look at another part of the plant, another area of the plant. And you can see here we've got a lot of large yellows and we have a red here as well. So let's look at this red one and see what's going on with it. And this could kind of show you the power of this tool. Again, we're going to see it visited with a photo of the asset. This is a high-speed spindle. And this particular spindle is high in the velocity area. So let's again see what the fault detection has to say. It says a high 1X component in the radial direction. Check for rotor imbalance. So we may have a tooling issue here. So let's visit the velocity and look at this waterfall and see what's going on. And in this particular one, and I know this probably doesn't affect people with motors and pumps, but in the machine tool area, I see a high 1x component that's up, down, up, down, up, down, each time we measure it. This is telling me that we have some sort of tooling issue or tooling imbalance issue, much like the fault detection told us. So let's go to that last reading and see what we're looking at for a 1x running speed component. And you can see, let's zoom in again. That's the tools that we're offered. So let's use that and zoom into the 1x. And you can see my amplitude here is 0.2 inches per second or 0.28 inches per second at the 1x running speed. That is clearly an imbalance that has plagued us. And let's go to another reading. And there again, we see it again. Maybe not as high, but still the same problem crossing the yellow. But on the last reading, it crossed the red threshold. So we can quickly see that we have a major imbalance problem. That number one, if it's not the tool and it's the spindle itself, we can correct it by pulling out our balancing app and correcting that asset point. But being this is a spindle and knowing that this is probably a tooling issue, this is something that we can address with the tooling department. But let's go back to this department and area and let's click on one of these yellows and see what's going on with them. And we see we've got another spindle here. We're going to go back to our fault detection, and here it's not saying an imbalance problem at all. It's saying bearings are unsatisfactory. So we go and look at our yellow here, scroll down to our very last reading. Well, we can look at our trend as well and see that obviously it was a problem before. It was replaced or fixed, and now it's been for months doing well, but now an incident happened and now we're crossing over the yellow threshold. And we can see that again in our waterfalls. We can see everything going well, and then the last few readings, things are escalating. So let's go back, look at the last spectrum and see if we agree with that. We're at about 2.7 Gs, which isn't I wouldn't put it in the red either. It's not going to fail immediately, but we definitely have a bearing issue here in the high frequency domain. Seeing our running speed over here and seeing that these bearing frequencies are elevated and heading in the wrong direction. So you can see again, this app can very quickly work with you and enable you to be able to find these faults and find these problem areas right away through this heat map. Okay, let's go back and switch to a different area from the Linamar route to the 2016 route, which is more of recent readings at this plant. And let's click on that same area, which was the Pentastar area. And you can see we're visited with a little more troublesome heat map with a few more active issues and problems. And let's click on this one here, and you can see here we have two alerts in yellow, both the velocity and acceleration. So let's again depend on our fault detection engine and see what it says. And in this particular case, it's not giving me one problem, it's giving me two. It's telling me I've got a 1x component in the radial direction to check for rotor imbalance, but also bearings are unsatisfactory. So let's drill down into that and see what we see. And again, we're visited with a similar waterfall plot here that's showing us that we're having a tooling imbalance problem that's coming and going, coming and going. And I even see a false reading here. I can see that somebody took a blank reading, which should probably be erased, but it's not troublesome at this point. But we can see, again, we have a tooling imbalance problem that may be causing a bearing problem. So let's drill down into the acceleration and look at bearings and see what's going on there with the waterfall plot. And again, we see it's starting, getting a little worse. And then here at the last reading that was taken, we've got a high peak right in the center of that bearing mass that's starting to plague us, along with this tall 1x running speed that is becoming a problem. So again, you can see the power of this tool, and we're just crossing the yellow threshold. So what we're seeing here as we drill into our last reading and spectrum, yes, we do have bearing defect frequencies, but we're only at 2.4 Gs, and we have a large peak at running speed, which is probably an imbalance that is causing this bearing defect to start rapidly degrading over time. So this is something that we can do to prevent this from happening. We can go back and balance this asset or solve its tooling problem and not put unbalanced tools into it, and we can stop this bearing degradation to happen. Or what I call this is being a very early onset detection of bearing failure. This is probably 6 to 8 months in advance based on what you've seen earlier, where we've hit 10 Gs and we need to remove that asset, whether it be a spindle, motor, pump, or whatever it might be. At that late stage, this is early stage failure, so we can catch things 6 and 8 months ahead of time with this application. So please consider this as being a very important part of the tool set that you have here, which we can again go into I won't get into too many details, but we can show the bearing markers and prove out that we're seeing what we're seeing. But it is very clear if we switch to velocity here and go to the last spectrum that we have a very strong 1 times 0.2 inches per second component that is actually putting a lot of energy into this asset point and causing bearing degradation over time. So again, let me click on something else that you should see. In the fault detection box, we can use this QR code to print out our QR codes so that we don't even have to, when we're walking around with our iPad, we can just print these out and hang them from the machine so that we walk up to the machine, use the iPad camera, and go right to that point without even having to highlight it with our finger and take our readings. It just goes there automatically and takes the readings. It's another feature I wanted to show with this web app. now let's go over to our ThermoPro app, which operates very much like VibePro. But let's open it up. And here you're visited with a little different hierarchy, but it's a hierarchy nonetheless. We can click on any one of these plant area, and these are going to be electrical cabinets instead of rotating devices, but we can click on a particular cabinet here, which is an electrical cabinet that they've been measuring. And you can immediately see where we've got our trend, much like VibePro. And we can see in this particular spot, we've got something well above, or not well above, but just above 150 degrees that is concerning us here in this particular asset point. So let's go to, this is the second last reading. So let's go to that second last reading and see what we're looking at. This is an electrical cabinet. The thermography picture was taken from the iPad. I can clearly see where my hot spot is here, and I can also look at the picture of the actual cabinet here too, which is taken at the same time, so I know what components I'm looking for, and I know what components are getting hot. But what I can also do is anywhere in this picture I can click and get a temperature reading exactly where I am, or I can use my cursor here and pull that out and see that, yes, this is my 149 degrees in this area that I've blocked out, so that I know that's where my trouble area is. I can go back and find out exactly what's going on with that hot spot. And this can work for motors, pumps, and all types of things. And of course, just like the other app, I can do a measurement report, or I can go back and do a plant report by plant area report. But let's click back into that and just do the asset report. It pulls it up. It's going to give me a nice trend, the min and maximum temperatures that were measured, and all that. And I can email that directly from the device. Or I can click even further and go to that measurement point and do a measurement report, which will tell anybody what I'm looking at, both from the thermography picture to the actual picture of the device, and what our problem area is here at 150 degrees. And all those tools are built into the application so that you can report to all the decision makers, or put towards the work orders all the information that is necessary to get these assets fixed and or replaced. So those are the two main or three main functions, which are the report center I started with, VibePro, and ThermoPro. We thank you very much for your attention. If there's any more questions at all, please reach out to us on the web at www.gtipredictive.com, or reach out to us at our number at 603-669-5993. I thank you very much for your attention.